Welcome to all new people. Uh, I guess we will start in 2 or 3 minutes. Just waiting for, I don't know, 50 more people, I guess, but uh, I guess we'll start on time. If you want, you can drop a line where you're from and just say hi to all others. Um, Here in Bulgaria is 3 p.m. I think there are people from all over the world, so thank you for joining us so late or so early your time. Um, and yeah, I guess we can start. We wait for a few more people, but that's fine. Um, yeah, today I'm really excited. We'll do our maybe one of the first free webinars of Automate the Planet. Um, I did this talk like uh, last week on a big conference called TestConf Russia, Moscow. Um, and yeah, I was really excited. There I had only 40 minutes for such a complex subject. Now I think we have more time, and I will try to show you, the whole tooling in a little bit more detail. And in the end of the presentation, of course, there will be some time for questions and whatever we can make a short discussion. Um, so yeah, today I will talk about how we can reuse our functional WebDriver test for wall testing, and um, the first part of the presentation will be, in short, basically, I will describe the problem, then I will talk a little bit about the default tooling or commonly used tooling for wall testing and common issues. Then we'll talk about the benefits of combining wall functional and wall testing and why we need to care. And of course, the biggest part of the presentation will dig deep into the code. But first, where are my manners? I bet that most of you know who I am, but let me, introduce myself again. I'm Anton Angelov. I'm from Bulgaria, and for more than 7 years, almost each week, I write articles on my blog, Automate the Planet. And yeah, basically, before automate the planet and creating my own company, I worked in Telerik and later Progress as QA architect. And right now, for more than 3 years, me and Martin and other guys, um, we have our own company working on consulting companies and using our open source tooling Bellatrix for you know helping companies for building test automation. So yeah, that's about me. Um, so let's start. Um, First, let me describe the problem. Keep in mind that I will use several solutions that later on you'll be able to download. Everything is open source and free. For the demos, I will use a demo website that we created for our Bellatrix tooling. It's called Demos Bellatrix Solution. It's basically I created this website just to write our automation and test it. So our test case here is that imagine that we have this online shopping cart, online shop, and we sell rockets. And as a company, we want to have this functional test here, automated test, but at the same time, we want to, have wall testing. I will describe that in a minute. What is it? But basically, for the functional testing, we want to be able to add an item to the cart. As you can see, it's using latest technologies. It's not reloading the whole page, but everything is happening asynchronously. When I go to the cart, here I can see my products. I can update them again asynchronously with the loading screen. I can apply a discount coupon. And then lastly, I can proceed here, fill all the required information and place the order. And probably there are many other cases that we can perform here. Like, for example, if I have at the end, I can check whether the account is created. I can log in if I'm existing user, and I usually expect here all of the data to be filled. Then I can go to my account and check whether the order was successful or not, and so on and so on. So this is our use case, and this is our problem. In a minute, I will show you first how we solve this problem with WebDriver in a few ways. But first, let's again talk about the wall testing. So I bet that most of you know what wall testing is, but just like a short reminder, the wall testing is a type of non-functional testing where we basically want to check how our website or application is behaving under a specific vault. We can get that from the server or the analytics, etc. Basically, we are performing the same test or a couple of tests at the same time on multiple threads or processes, as you'll see later on during the presentation. So here I listed a few popular wall testing tools. Maybe the most prominent and most famous is Apache JMeter. It's free. Another similar tooling is Gatling. I think it's more, it's popular because you can use it to create even a bigger vault with it. These are the two from this list that I used professionally. However, in my professional experience, back in the days, in Telerik and in Progress, we used highly Visual Studio wall testing, but I think last year it was deprecated. So yeah, what are the common issues with this kind of tools? In a minute, we'll go through the list of the issues, but as you can imagine, most of these tools are UI tools where usually basically you click the record button, you record all the performed requests, and then these tools are responsible for creating the multiple threads or processes and performing the re-recorded version of your test. And depending on the tool, you can customize the tests, perform some kind of verifications, probably do some kind of data-driven tests. Um, and yeah, so what are the common issues? First, at least in my experience, these tests get out of date quite fast, especially if you make changes to your, for example, website. It's quite hard to maintain them because, as I said, usually, uh, you record the requests, but depending on the tool, sometimes it's really hard to edit them afterwards. For example, in Visual Studio wall testing, we actually had the opportunity to export the recordings to C#, but their low-level API for the wall testing was quite ugly and really complex. So it was really hard to, edit later on. So this leads to non-maintainable tests, and the thing that we do in the whole company was just to basically re-record these wall tests when needed, instead of trying like at the same time changing them manually. And this is the usual practice that I observe in many companies that I consulted. Um, Sometimes it's really complex to write complex scenarios. By complex scenarios, I mean, for example, imagine handling this asynchronous stuff that I showed you on our website, or imagine that you don't want to perform the wall test with the same user, like right now. Imagine that we want to create a wall test with every time with a different email, and then have activated user and have a different passwords, etc., to log into the account. This means that you want somehow to, I don't know, create a coded solution with a lot of users to create a data-driven tests. In usually, most of these tools are made for much simpler scenarios. Somehow we managed to do this kind of a complex test in Visual Studio for wall testing, and I think most people can do the same in Gmeter, for example, if you write some Java code. But still, it's a little bit more complex than just reusing your WebDriver tests. Another thing that I noticed is that, again, depending on the tool, some of them lack of advanced verifications. Usually, as you know, if you do post requests and then the response body is returned, most of these tools allow you just to, for example, check for particular text whether it's present in the HTML or not. But basically, the verification is just contains. It's not, you're not able to use XPath or whatever to locate a particular element or wait for the element to appear and stuff like that. Again, it's doable, but even if it's doable, it's really hard to do depending on the tool. And then, of course, if you have this set of WebDriver tests and then the wall tests, you need to maintain both of these sets or test suites, which is again a cost instead of just having one set of tests. And usually the technology and the language are different. And depending on the tool, there are high licensing costs. And this was the case for Visual Studio for wall testing, because in order to be able to use it before, you had to purchase enterprise license, which was like thousands of dollars. And then later on, they switched to some kind of a cloud subscription with wall testing minutes on agents, and yeah, a lot of money. So what are the benefits of combining functional and wall tests? First, you can get really, if the framework you use support this, basically you need to write just the WebDriver test, and then you can really fast can create wall tests. So you don't need to learn custom wall test scripts. We had to learn, because almost of all of my professional career, I worked in the .NET world. When Visual Studio for wall testing was deprecated, we had to learn, Gmeter, and since it's outside of the .NET world, we had to learn Java-like languages, etc. It's not a problem, but just this, it's a different language. So the switch, sometimes it's hard. So if you use your WebDriver test for the wall testing, I think if you use a proper framework and if you wrote the right framework yourself, usually these tests are quite more maintainable than the regular wall tests. Depending on the solution, it will be really cool if we can reuse the verifications and the locators and so on. Later on during the presentation, I will show you a few design patterns and ways how you can do that. And since it's open source free, the only cost is that you need to maintain the test. That's it. But you don't need to pay for it. And now let's dig deep into the code. I'm not a fan of long theory lectures. Long time ago, maybe most of you know, I wrote a book called Design Patterns for High Quality Automated Tests, and now I will show you a few examples from it to understand a few patterns that we used in this library that I will present. I will use again some of the code examples, which are absolutely free to download. If you go to GitHub Automate the Planet, here you can find the GitHub repository design patterns for high quality automated tests, C# edition. These are all demos from the book for all of the chapters. And now I will, in order to explain the Decorator design pattern that we heavily use in the wall testing solution, I will use the examples from chapter 2, stabilize the tests. So you can, it's freely open source. You can download it and check it. I already opened the solution here. In the book, I use again the demo website that I showed you before in the same use case. So yeah, before showing you the examples, let me just return to the presentation just to explain what is the purpose of this. But maybe we need first to show you the dummy approach of resolving the same issue. So here I created a first version of this product purchase tests, which is like, imagine that I'm a junior developer in test and I'm inexperienced. So, and I wanted to create this purchase test. The usual way to do it is to place everything inside one test, the locators, working with the buttons and everything. However, this is, by the way, MS test project. Here in the class initialize, this is executed before all of the tests, and after all of the tests, we close the browser. Here we use Chrome. At the beginning of here I have 3 tests. Basically one with new client. When we have the account, I coupled the test, which is a bad practice. So we expect that this test will be executed first. Then with the same account here that it's already created, I log in so that we can, my data to be previewed in the shopping cart. And then the third test is just going to the to my account to check whether the order is there. Again, following all the best practices, I'm coupling all the tests. But this is like I'm following one more best practice, and this is in order to handle these asynchronous loading screens. Instead of using, like later on I will show you in version 2 and version 3, here I just use hard-coded pauses, which is awful. Like again, here if we count all of the pauses here, it's 2 seconds, 2 seconds here before updating the card. This is really bad because sometimes this may load under 2 seconds. Sometimes, depending on the load on the website, it can be loaded for 5, and then this test will fail. And since I coupled the other two, all tests will fail, which is really bad. If in case the website is fast today, then it may load for 500 milliseconds, and then I will just wait for a second and a half. But you can imagine if you have 1,000 of these tests and you wait for additional 20 seconds for each one of them, how much time you spend just waiting with hard-coded pauses, which is awful. And I'm not discussing even here how hard this is for reading and how much code duplication there is with the locators and everything. But as you can see, this is really a bad practice. So what we can do to, one way to improve a little bit the test and at least remove the hard-coded pauses is that I created here two helper methods using the so-called explicit wait in WebDriver. This explicit wait basically is this WebDriver wait class, which allows you to wait until here the element to appear, and then I can perform some kind of operation. So I created this wait and find element method, and I return it. And this is one way to solve the issue. Just ignore, this is not the best name. We'll fix it in version 3. But basically here, I will be sure that WebDriver will wait for me the appropriate amount of time, then we will return the element. So the same test here, instead of using driver find element, I use my wait and find element helper method, where for each element I will wait, and then I will click or type, etc. And as you can see, there are no hard-coded pauses, which is a great improvement. And one more thing here, I created another helper method called wait to be clickable. I use these expected conditions. If we click here, func, which is a delegate in C# or a pointer to a method, it comes from this NuGet package .NET Selenium Extras wait helpers. So we wait for the elements to be clickable because sometimes the element is there, but basically you cannot click it. So this is version 2, and now it's time to show you what the decorator pattern is and how we use it. You can think of the decorator design pattern as a wrapper. This is why basically here, as you see in the demo, we create wrappers for the native element, the iWeb element, and for iWeb driver, basically the driver itself. And the whole point of the decorator, it has for me two benefits. First, I can add logic to some class that it's not mine without, or even if it's mine, I can add logic without modifying the existing code that I created, following solid principles. I'm not going to explain right now what solid is, but basically one of the principles in solids is that you need to create classes that are open for extensibility, but closed for modification. Because every time you modify some of your classes, you add the possibility for regression. So here with the decorators, basically the decorator wraps this here wrapped object, the driver or the element. Then we create, this is basically an abstract class. Here we define the API or the methods that the new API will have. And then each decorator basically implements the new API, calls the wrapped component, and then adds the new behavior. And then we can nest inside one another the different decorators. When you see it in a minute in the demo, I think you will get it. Then we have this component class. Again, it's abstract or interface, where we define the different methods for the wrapped component, and then we have the concrete components. So we will have this implemented for the driver and for the native element. And the thing that I will try to do, and the great thing here, is that we can improve the naming of the methods and maybe the usability of them. And maybe we can add new methods that, for example, my driver don't have, or the element too. So let me show you the demo in version 3. Again, I use here the demos and the much more detailed explanations from the book. But again, later on, we will switch to another solution where I will show you the whole testing engine itself. So if you recall, we need to first here have this abstract components. This is the abstract component for my driver. And here I removed some of the methods from the driver that I don't need. I just clean the API, so to say. Here I have two methods, find element and find elements. Here basically we remove, we return not the native iWeb element, but basically our concrete component for the element or the decorator of it, the improved version. You will see in a minute. Then we have a go to URL method, where basically we will navigate to the page, one quit, which will close the browser. And then here we have this start method. As you see here, we'll implement another design pattern called factory method that we use it to start the browsers based on this enumeration here. This is the type of the browser. Then we have a similar component for the element itself. Again, this is an abstract class. The improved API here is that, for example, here I added a new property, returning the byte. Usually this iWeb element, it doesn't know how it was located, but our improved version of it now knows how it was located, and basically we will use that in this WebDriver weight explicit weights, which is a great improvement. And we improved one more thing, and this is that instead of using these send keys and clear methods for typing, right now I improved the API, improved the readability by renaming this method to type text. I think it's much better name. Again, there is a reason why in WebDriver this is called send keys, and this is because you can, for example, send keystrokes from the keyboard, for example, pressing enter and such. But right now in our framework, we don't need to do that. This is why I just renamed the method to type text. So yeah, let's see right now the concrete implementation of the driver. Here it is, WebDriver. As you can see, we implement this abstract class, the driver. And this is the place basically where we use composition. The composition is the approach where basically we hold the private variables of some of the, for example, for the WebDriver or the component, instead of using, base classes. And here, as I said, this is our factory method. This is another design pattern, basically where, based on this enumeration here, we initialize the proper driver. This is not so important. I'm just mentioning that here we use this pattern. This is like a helper utility method. Then again, instead of using this long navigate and then go to URL, we improve the usability of the API by just having this method go to URL directly without using this navigate. And then here in the find, as you can see here is happening the magic, where instead of having this wait and find element method, basically we have only find element. We again pass here the native Selenium by locator, but instead of returning directly the native iWeb element coming from the Selenium library, we return our base class for the element. But here we do a few things. First, we wait for the element to appear on the page. So when we use this find element, basically we wait every time without hard-coded pauses. Then we will create the concrete component, the web element that will check this implementation in a minute. And then we wrap it here in our decorator. That basically this walk element is our decorated element where we have this new requirement where we want for each, after each action against the element to perform some kind of a logging. In a file or on the console, that's fine, no matter. But instead of just every time going here and adding the new behavior, the logging or, for example, some kind of an analytics, we basically extend that through the decorator. And we do that for the find elements, it's the same. So let's now just check the logging driver. This is the driver decorator where we added this logging behavior too. As you can see, we have this driver decorator class. Again, we use composition because we nest the different decorators inside each other. And here, basically, I'm just calling through the composition, basically the composed element here. And the actual decorator, here's the logging decorator. Again, we pass the base component here. And as you can see here, we add the new logic and basically we call the original method from the driver class. And basically every time when you nest the different decorators, we add the new logic and we use some kind of a recursion here to call the different decorator logic. So that's it. For the web element, again, we use composition. We pass here, again, through the constructor, the different needed parts. And basically, we are just calling, again, the native WebDriver attributes and methods. Just here, again, for example, I improve the clicking. I wait first for the element to be clickable. Again, I use here the new by property. So right now the element knows how it was located, and then I click. Again, the type text, as you can see, instead of every time have clear and then send keys, I just use type text, and so on. And here is the walk element. Again, this is the decorator for the walk element. Again, I am calling, before calling the actual method or property, I am performing the logging operation. And if we look into the test right now, here in the class initialize, instead of just creating, for example, Chrome driver, first I'm creating the decorator, the logging driver, and then inside its constructor, I pass the actual implementation of the WebDriver. This is the concrete component. And as you can see here, we use this factory method to start the browser. Here we close it. And as you can see here, basically we the test is reading almost the same. But right now here, instead of returning a web element, we return the element itself, which is the decorated element, which have this improved API with the type text. And moreover, here in the find element, we'll wait for the element to appear and then we will return it. Here inside this click, we'll wait for the element to be clickable and then we click it. And we removed all the pauses, which is really great. So yeah, basically this is the decorator, and I needed to explain it in order to understand the design for the wall tests. As you'll see, we leverage a lot of it in the wall testing solution. So let's now start with the whole thing about the wall testing engine. First, in the solution that I will show you, basically, by the way, it's part of our open source framework called Beatrix. We open sourced it a few months ago. Um, so I created like for the conference, like a port only for the load testing solution, but this is just, you know, for demo purposes, in order to show you the engine and everything in simplified way. If you want, you know, the whole version of it, the whole framework is free and open source. And here under load testing folder, you can find the whole solution with all of the methods. I'm just going to present the short version because here there is so much code that, you know, it will be hard to explain. So yeah, basically you can download it and see it. I will just use this, you know, short version. And in the end of the slides, you'll be able again here in my GitHub repository to download the short version again. So I will try, we won't have even the time right now to present everything in much detail, but I will try to give you a high-level overview of the whole engine and the algorithm and the whole idea of how you can reuse the WebDriver test for load testing. So yeah, basically we need a module for capturing the HTTP traffic. I will show you one implementation of it, and then I will explain how, for example, in WebDriver 4, what you can do when it's official and how you can use it in Chrome. Then we need, as you will see, when we execute the test, we basically every time when the test is green, we capture the HTTP traffic, and then we save valuable information about the requests and, for example, perform assertions and how the elements were located or not. We save that into a JSON file. So we need a logic for be able to do that. Then, of course, we need the load testing engine itself that will create all of the, you know, threads, parallelization, and everything. Then we need, as I said, a real drawback in regular load testing solutions is this verification engine and how you can get the elements in the return response. So I will present how we managed to do that. And of course, the report generator, this is like a fancy HTML report or whatever. So here I will leave this for the demo. And first I will show you what we want to do, and then I will go into the deep, into the code, into everything. So first, in this like short version of the code, I have a few projects here. First, in this end-to-end tests project, it's .NET Core. Here, I think we use MS Test. Yeah, MS Test. We need these 3 packages. And basically, I have the same test that I showed you, version 3, using the Decorator design pattern. Just a few of the names are a little bit different, but it's the same logic. In order to be able to, you know, keep working this verification engine, I have added additional method here to the Decorator. We in Bellatrix call these methods ensure methods. The whole point of them is that instead of using this regular assert API that comes from any unit MS test, here if you use this approach, basically we'll get the text directly from what is inside. But as you saw in the example, usually, for example, in some of the diffs, the information is loaded asynchronously. And this is why sometimes this will fail. Basically, inside these ensured methods that we have in Bellatrix, we wait, again, using this explicit wait underneath, we'll wait for example, this text to show up for 30 seconds. And I added this, if we navigate here, to the interface of the I element or the abstract class, whatever. And here in the concrete component or adapter, I implemented this ensure text this and as you can see here, basically we call this WebDriver wait, and we use this method text to be present in element. This is again a func. The func again is a delegate, special delegate that has a return type. It comes from this Selenium extras wait helpers. And here I add, as you'll see in a minute, an additional logic for saving this information to the file that I told you about. So as part of this solution here, nothing else have changed. I only added a configuration file here. If you're not sure how to use this, I wrote an article a long time ago. It's on the website, how you can, on Automate the Planet, how you can basically use this kind of a configuration data in your tests and be able to switch between the different configurations. So I have here information about the logging, the API, but the most important part here is this load testing section in this JSON file. First, I enable here the load testing solution. I mentioned the default host or the default URL. I mentioned here that I want to record only the requests that come from my website. Here I mentioned where I want to store this special JSON file that I will show you in a minute. And if the website is under HTTPS, here I can add a path to the certificate so that we can, encrypt, decrypt the traffic. And then here I can use regex expressions to ignore certain URLs. So this is my basically end-to-end test. And if we want to store the information, as I said, I will explain in a minute how we do that. But basically, the JSON file that we store all of the requests and the information that we need looks like this. As you can see, this is only a single test and how long it is. But basically here, we have an array from all the information that we need. Basically, we have the URL for the request, the different methods, the headers, the body, when the request was created, and for how many seconds we need to wait between the different requests from the queue. And then another interesting thing that we save here in this JSON file, if I scroll down to the bottom, you will see that we have this request modifications array where we store different information that we type, and later on we can use attributes to, for example, if you use a data-driven test, to exchange this information with other values. As I said, sometimes you want to change the email address or the password for each particular thread. And this is how I know which information I need to exchange and replace in the request body. And another interesting thing is that when we use this ensure text is methods, basically we store what action we did. Basically here we say we assert the text, we save the value that we need to check, and we store how the element was located and what was the locator value. Later on, we will use this information to be able to perform this kind of assertions inside our load tests. Basically here I implemented only this ensure text is. Again, this is just a short version of the load testing library. If you want the full version and check how it is implemented and everything, download the open source tool. And as you can see here under Bellatrix load testing, you will see how many ensure methods we have. Basically, we have so many helpers. Again, for the web version here, we have the same, as you can see here, for all the different HTML attributes. And we implemented the same for the load testing because we reuse this Bellatrix web. But just for the demo purposes, we have only one. So yeah, this is the file that we that it saved, and right now we have one more project These core projects, I will show them in a minute, but basically we have another project where we basically hold our wall tests. The whole idea is that when you run in continuous integration or on your machine this type of tests, these JSON files, they will be always be up to date when your tests are green. When your test is green, this file will be generated, and you will know that if you make some kind of a change the locators or add a new behavior to the test, every time this will be re-recorded, and you will be sure that your wall test will be basically up to date, because we use only this JSON file for the wall test. Then our wall test, we have an additional library for it. Basically, this is one of our wall tests. The core logic is in this vault.core, or in Bellatrix, this is the Bellatrix for wall testing project that I showed you. Again, we have a similar configuration. It's almost identical to the one present here into the end-to-end test project. And we need a few things here to configure. Basically, you are defining your wall test through code, which is really great, instead of using some kind of a UI. First, you initialize and create this wall testing engine. And you need to configure all of these settings here. I will show you in a minute how this works underneath, but just let me explain what settings we have. First, here for the wall testing type, we have two types. We can execute the wall test for time, for example, for 10 minutes, or a number of times, 1000 times. Then there is this mixture mode. What is the idea of it? Is that, for example, if you have 5 scenarios, logging to the website, submitting a ticket, purchase a product, etc. In most cases, you want just to execute all of them equally, but sometimes you want one of the scenarios to be executed more often than others. Then you can use this weight mode, where you can set percentages between the tests. Then here, for the number of processes, you mentioned how many processes you want to be generated, our wall test users. Here you can set pauses that can be between the different requests. Here you can mention the seconds that the test will be executed, the total seconds. Here usually I use true. This means whether we want to simulate the real timing between the requests, or if this is set to false, basically you just fire them immediately when one after another. This is why basically we saved into the JSON file this, if you recall it here at the beginning, this information here, milliseconds pause after previous request. Basically, if this is set to false, we'll just pause with this amount of time. Then here we can reuse regex expressions right here to ignore certain URLs. For example, you can ignore here all third parties like Google Analytics or Facebook Pixel or whatever. You don't want to wall test them. And here again, you can use just full test name with the namespace, or you can use regex expressions to include the different scenarios that you want to execute. And the last part here in the assertions is that by default, the engine will verify that all of the statuses are successful or not. And the coolest part here of this engine is that mentioning this assert all recorded ensure assertions basically will try to reuse the locators and everything from the WebDriver to perform the same assertions in the wall test, which is really great. And then when we call the execute method, we'll save the results in this HTML file, which is the results, how it looks like. Basically, this is the report that we generate with a few free libraries. Here I generate the chart through some, like I will show you I generate the JavaScript and the HTML, and we have information about the different requests and the exceptions and the timing, etc., and all the fail assertions, and so on. Like some basic information. What else? I guess we can just dig deep into the engine, just to show you the different parts. First, let me show you the first part about how we capture the HTTP traffic. How we do that, if we navigate to our end-to-end tests, you see here that we have this base test. We need to derive from it, all of our test classes need to derive from it. So if I navigate to it, you see that it's part of this web.core. And here I do a few things. First, I have through composition, I use this wall testing workflow plugin context. Again, this is a simplification of the whole extensibility plugins in Bellatrix, but basically this is responsible for capturing all the needed information for the wall tests. But here we use this proxy service. This proxy service, as you can see here, it started before each tests. Here I initialize the Chrome every time. And if the wall testing is enabled, basically I start the proxy service. I create a WebDriver proxy that it's listening on the port where the proxy service has started. I initialize it, and as you can see here, we basically use the same decorator pattern to wrap the Chrome driver. So when you start executing the test, basically this proxy allows you to, if we navigate here to the proxy service, basically here, this is an open source C# project called Titanium Web. It comes from this library here, this NuGet package, Titanium Web Proxy. It's open source project. You can find it on GitHub. It's really great because it allows you to, like here, be able to execute logic before the request, after the request. You can block certain requests, and so on and so on. There are a few articles on my blog. One of them, I think it's part of the book. It's called Black Hole Design Pattern, I think. So we use this Titanium Web. Here it is. You can read it for free. Here, this is the whole chapter about the black hole proxy pattern. The whole thing here is that we basically block all of the unnecessary requests, like, again, analytics and Google Pixels and such. I'm not going to explain it in detail. Again, I wrote a second article about the Titanium Web. You can read it on the blog. It's not so important. So one way to accomplish the thing that we desire is to use this Titanium Web. And the thing that we do is that we use this proxy service to listen on a particular port. And as you can see, as part of our wall testing workflow plugin context, I have this method here. Ignore the complex logic here. This is part of the, as you can see, this is asynchronous method, because the proxy usually listens in parallel for the different requests, because some of them are happening at the same time. This is why here we basically use await, which is asynchronous. Basically, we'll wait for this logic here to be executed, and then we will return the result. We will not talk about awaits and async, but basically here we start a new task or a process. And if you ignore all of this complex code here, the main and interesting part is happening inside here. First, in this should filter, and basically should filter request. If we go here below, you will see that we're for eaching all of the regex expressions that I mentioned in the settings or into the configuration. And through this regex match, I will check whether we should filter the request or not. And depending on whether we should filter or not, if we don't have to filter, basically we store the request information in this collection here. As you can see, this is a really complex collection. It's called concurrent dictionary from string. This is if we return our key is the test name, the full test name, and the value is basically a concurrent back. These two collections, they come from system collections concurrent, which is a generic version, special generic version of the collections in C# that allow you to basically be able to handle multiple threads and without and handling all of the deadlocks and everything. I saw that there are a few questions. When we finish with the presentation, I will be happy really to make a discussion and to answer all of your questions. So basically here we store for each test basically a list of all requests. So the concurrent back is a representation of the list, but just a concurrent version of it. So ignoring all of the complex code here, basically we store, as I said, this code here, this method or a task or whatever will be executed before each request. And this is through the help of this this proxy service that basically is triggering these events. So one way to do it is through this proxy Titanium. Another way is if you go to the blog. I wrote an article like a month ago, I think, about WebDriver 4. It's still not official, I think, it's still in alpha, but they introduced, I walked through here through all of the different new cool stuff that they will introduce. But maybe one of the coolest is that you will be able to use Chrome DevTools inside WebDriver tests. And basically you can, again, this API may change, and this is what they said. But basically, instead of using this Titanium web proxy, you will be able to use Chrome DevTools to do the same thing, like you can do from here, for example. If I open basically a network and click record, you'll be able to do the same thing. So maybe I'll just rewrite the engine to use this Chrome DevTools. However, the Titanium web proxy is working for all web browsers. So, and Chrome DevTools is working, of course, only on Chrome. Yeah, so let's continue. What else do we have in this whole testing workflow plugin context? Well, if you recall, first we need this capture HTTP traffic logic. Then we need a logic to basically, when we have this dictionary, concurrent dictionary for all of the requests for particular tests, and then we store all the assertions and everything, we need to be able to store them on the disk after the test is completed if the test is green. How we do that? First, we do a few things. Here we have this pre-test initialize phase where basically, again, as you can see, we store here, we initialize this concurrent dictionary, but here all the magic is happening in the post-test cleanup, or basically after each test. If the load testing is enabled, we get the directory that we mentioned into the configuration file. We create a directory if it doesn't exist. And basically we are using JSON serializer to serialize this concurrent back from the request to the JSON file. Basically we are converting the collection to JSON. And then we are basically saving to the disk the file. That's it. And if you see where I call this in my base test here inside this test cleanup. in the test cleanup, I call the post-test cleanup part of this workflow plugin context. I close the browser, and then I close the proxy. And then before each test again, I will start the proxy, I will start the browser, and I will initialize the whole testing engine here. And then about the whole testing engine, let's now see what we do here. When we have this file again, this is the needed thing for our wall tests. If we navigate to our wall test here, not here, but here, the test demo, we have this wall test engine. This is basically here there is even more complex logic, but yeah. So we have again here the concurrent dictionary. For each test, we hold this bag of requests. Basically, this HTTP request DTO or data transfer object. This is DTO. Usually this naming is used for objects that are used between in web services that we serialize them to XML or JSON. So basically, as you can see, this is a similar thing to one of these basically rows in our array of requests. This is the serialized version of this request DTO. And we use that later on for the wall tests. So we initialize all of this stuff here and we read them from the file. As you can see here, we read them from the file. And here in the execute, we do a few things. First, we have this test scenario mixture determiner. This is used to determine whether we need to execute the tests equally or based on these weights that I told you about. But again, this is maybe not something really important. But as you can see here, based on the settings, whether we need to execute it for time or number of times, we use this whole test service. And we have two methods, execute number of times and execute time. So this is something interesting. Let's go here. If you see here, we have a few verifications and then we have a stopwatch. Basically here we measure the time between for the whole test scenario. Later on we save this to test results file. But we do a few things here. In the execute for time, here we do a do while where we wait for the total seconds to pass. And in both places, we use this create test tasks where we pass the number of processes, whether we need to pause between the different processes, and this action. The action is a delegate in C# or this is a pointer to a method, as you'll see. Basically, this is a method, or this is our test scenario. If we navigate to this create test task, we do a few things here. Based on a number of processes, as in our example 100, we create 100 basically tasks or threads in C#. We use the TPL library. This is coming from TPL, which is the task factory here, TPL, system trading tasks, TPL. And through this factory, task factory class, we start a new process for basically the test scenario. Again, this is our test scenario, or the whole requests repeating and everything. And when I start all of the threads in parallel, we use this task wait all. Again, this is from C#. We'll wait for all of the tasks to finish, and then we'll, for example, run them again and so on. Basically here for the do while, we will repeat that. When all of the processor finish, we will repeat that again and again and again until the time finishes. So this is part of this wall test service. As you can see here, as I said, here from the settings, we pass the number of processes, in our example, 100. And here we pass this execute test scenario. As you can see, this is a method. This is our action. This method here, basically, I provided this as a local function here. The local function comes, I think, from C# 7. This is function inside the function in C# instead of, this can be like a private method, that's fine. Basically here, the interesting here is this test scenario executor. Basically, this is the thing that will do the actual requests. If I open that, as you can see here, we use this REST client. I use here REST sharp. This is the thing that we use in Bellatrix for API testing. So here we provide this test scenario. The test scenario is just a class where basically we mention the test name and all of the requests in this concurrent back, and how many times need to be executed, how many was executed, and so on. So again, we use stopwatch to measure the time for the test scenario itself, not for the whole bunch of the requests. And as you can see here, basically we are for each of the requests part of the scenario, or basically from the JSON file. And we check here whether we should filter or not. And if not, if we need to, here we execute this basically the pause between the different requests. And there is a complex logic to pass the state of the cookies. I will not go here because it's really complex how we, for example, when we perform a post, and then if the server is returning the cookies here, there is a really complex logic for passing the cookies between all of the requests, but I managed to write that. It's working perfectly. But yeah, basically we have this complex logic here for updating all of the cookie collections. And then there is one more interesting piece. Here we get whether the request is successful or not based on the response. And then we have this load test assertion handlers. We get here to this point, verification engine. In order to do the verifications, we need a few things. If I return a little bit to our load test engine, if I scroll down, you will see that we have two things here that we initialize. The first thing is this ensure text is handler. This is responsible for locating the elements in the response HTML. And then we have these locators here. This is part of this verification engine. What is the logic here? The logic is that when you perform, for example, a post or a get, the server is returning in the body the HTML, that it's rendered on the page. And then we need, based on the information that we stored here below, based on this locator, we need somehow to, using this XPath, to parse the HTML and then to understand whether this value is there or not. And how we do that, we use a few things. First, we have this test locators based on the different locators that we have in Bellatrix or in our engine. And here we use a special library called HTML Agility Pack. This HTML Agility Pack allows you, if I go here, basically it allows you, let me see where we use it. Here I create an HTML document. This is a sharp object. And then I use this load HTML method, part of this HTML Agility Pack, where I provide the HTML body. Again, if your website is under HTTP, we have a logic inside the in our proxy service where we use this basically HTTPS certificate to decrypt everything. So here we have decrypted HTML. In this content, we load the HTML into the memory, and basically this HTML document is the representation of the DOM. Later on, when we create this based on the locators here, based on the type of the locator, I decide which one of these bilocators to call. Basically based on the thing that I mentioned here, based on this value here. Based on it, I'm choosing which one of them to call. And then I have implemented this part of this abstract class where we have abstract method locate element, where for each particular type of locator, as you can see here, we use different logic from this HTML agility pack. For example, right here, I'm using XPath for locating by class the different nodes, and then I'm returning them, the first that I locate. For the ID, there is a special method called getElementById. And again, yeah, there is one for CSS and so on. So we use this by XPath wall test locators to locate the different elements inside this memory version of the HTML DOM. And then we have this ensure text is handler. This handler is used again based on this assertion type here. We are calling the particular handler. This is how we locate it from the list of all handlers. And as you can see here in this execute, basically we are calling just the execute of the handler. We provide the element that we located into the memory using the HTML agility pack. We provide the expected value again that it's written here. And the thing that we do is that at the end we return this response assertion result, which is an object that basically holds the whether assertion is successful or not. And we will print that into our HTML report. And then we have access to all of the attributes and everything of our web elements. And we can do this kind of assertions here. And as you can see here, if this is not true, we'll message that this failed, and we'll create a failed message. Basically, that's it. And if we return to the wall test engine, as I said, basically this is one of the things that we do here in the execute. Basically, after all the requests are performed, and we have a logic to track whether the response body was HTML or not, because there are many requests that are just, for example, loading JavaScript or whatever. We don't need to perform the assertions. We have a logic that we know that we need to execute this at the right time, and then we will store the results. And I think this is maybe the most important part for the wall testing engine. And let's see, lastly, the wall test report generator. As I said, we want to be able to create this kind of HTML reports. How we do that? In this report folder, I have this wall test report generator. And here I have a few methods. One public, generate report, based on this wall test run result object that I pass, and where we need to store the report. And as you can see at the end, we just write the file to basically the string to the file system. Here, in order to simplify the thing, I created basically a template, report template, where I have all of the CSS, and I added a few placeholders. As you can see, we have a placeholder for the HTML and for the JavaScript. Because if we see here the generated report that I showed you, there is a lot of HTML. This is all of the tables, and then we have this JavaScript for visualizing every time the different charts. So again, here we have two methods. Basically, we have this scenario HTML report generator that it's used to generate the HTML, where we provide again this wall test run results. And here we're using a string builder through a for each we're creating the different tables, HTML tables based on the particular values. then when we have this string here, basically we are, as you can see here, we replace, when we load it into a string, the HTML template, and we replace the placeholder. We do the same for the JavaScript. Again, through a string builder, I'm generating all of the colors and everything and all of the JavaScript in a string builder, and then we replace it into the template. And then we, of course, we save that to the hard drive. So this is how we generate the report. A few more things. You can find the full documentation for the wall testing here in our other website, Docs Biotrick Solutions Web Automation Wall Testing. Again, as I said, this module is really huge. I showed you only a small part of it. Only the ensures are like tens of thousands of them. And there are many more configurations and stuff. You can check all of that here, is really well documented. What else? Also, we started to do trainings and like in 3 parts. The first part is really getting started from C# level 1, getting started with WebDriver, setuping continuous integration jobs and such. The second part is really more advanced stuff, like really hardcore C# with all the new features, etc., and showing all the different report solutions like Allure, Report Portal, executing tests in Docker, setuping Appium emulators and simulators, working with locating, locators for desktop apps, and many more, and more advanced stuff about the WebDriver. And then we have this third part where basically I teach for 30 hours how we can create a framework similar to our Bellatrix for your own company and custom framework. Of course, this is built for 3 years. I cannot explain everything, absolutely everything in 30 hours, but the whole goal is that we start from scratch based on based on the stuff that we teach here to create all the different parts. And my idea is that you can find each week I started to talk about this custom test automation framework series, free articles. Later on, maybe there will be a book about this. But basically here I explain again in so many details like right now. I will start to explain how to implement each one of these different features and everything, and design patterns. I'll try to explain them in a separate articles. So you can check their 2 articles already. I will create such articles each week. And also we plan to do this kind of a webinars like more often, so stay tuned. So before proceeding with the questions, I want to mention that there are a few enhancements that we can do to this kind of a solution. The first one is that I haven't managed to do this data-driven thing that you can bind some data and then change it for each thread. But as I said, this is part of the design. This is why we stored here this information here about the request modification. This was the idea. Then maybe we can add some logic for capturing the CPU and the RAM and some other metrics, and then add them to the report, because this is important. Maybe there can be a better integration for distributed execution. For example, integrating this in distributed runner like Mesa. And maybe we can add some more data to the report. So yeah, we discuss many things like common wall testing tools, some issues and the benefits, and I showed you a lot of complex code. You can download the full solution here from Bellatrix Solutions. You can check there are many free articles here on Automate the Plant about the different design patterns. This is the short version that I showed you from the examples. You can download it from here. I think we'll upload the video to the website maybe next week, and there I will add a link to this presentation. Here you can download the examples from the book. And now it's time for questions. You can type them into the chat or in the Q&A. I think there's already 3 questions. The first question is, can we download this lecture from somewhere and watch it again? Yes, I will upload that. I usually upload this kind of lectures to this section here. If you go to the blog, you have it here in resources, and then in special editions, I usually upload, when I do talks, I usually upload the presentations and the videos here when they are available, and you can download the slide deck, and usually I provide the source code. But again, even right now, you can just go to my GitHub repo, Automated Planet, and download first design patterns for automated testing, and then if you navigate to my profile here, Angelov, actually, I'm not sure. Anyway, it's like this, Angelov, ST Anton. Here you can find the popular repo combining quote functional testing WebDriver. This is again the short version of it, the simplified. But again, you can just download the full source code here, and the particular projects that you are interested in are this Bellatrix wall testing and the Bellatrix web. And I suggest you to go with this web getting started. This is a getting started project explaining all the features of the framework. And I think here there is a folder about the wall tests. As you can see, this is the most advanced thing here. There are all kind of explanations, and you can find the same thing as part of the documentation. Again, docs, here in the docs. Web automation wall testing. If you have any other questions, please free to ask, or I guess we can wrap up if you don't. I hope that it was interesting for you, and I hope you like it. I know that the code was in some parts a little bit more advanced, but I'm sure that when you download it and maybe debug it or play with it, you will be able to understand it. Anyway, if you don't, please free to just drop me a line on the blog on my email, and I will be happy to answer, or just drop me a line in GitHub, that's fine, or in LinkedIn. I will be happy to chat. Yeah, we'll share the video again soon. Just I will remove the first 10 minutes that we were not talking, and then I will upload it. So yeah, thank you for joining us late or early or in the middle of your working day. Stay tuned. As I said, we plan to do this kind of webinars each few weeks. When I have a good topic, again, I will just show you, I will just email you and share with you when there is something that I want to talk about, and we can gather again, and I will share something with you again. So thank you, take care, and see you next time. Bye.